Hi, welcome to Imperium Learning. Today we're just going to be talking about autocorrelation functions and partial autocorrelation functions. I think the main part of this video is really directed towards being able to look at the traits of your variable's data generation process and determining whether or not it's characterized by either an autoregressive process or alternatively a moving average process. And just from the outset, I think it should be noted that you can't do one or the other. You have to do both, and you have to read them together in order to get a clearer picture of the features of your variable. So just moving quickly on then, we're going to start with autoregressive processes. Now, what is an autoregressive process? Well, an autoregressive process is really just when the dependent variable, which we can denote as yt, is dependent solely on its own previous values, as well as possibly a constant or as well as an error term. So I've just got an example here of an AR1 process, which is yt equals mu plus phi yt minus 1 plus ut. An AR2 process is the same, but in addition, it's also got yt minus 2. So the key right here is in the subscripts. You see that the number in brackets means the number of lags of the dependent variable that it's got as explanatory variables. So that's the key thing to bear in mind. If it was an AR3 process, it would have yt minus 3 as well as yt minus 1 plus yt minus 2. So the question then becomes, how do you actually identify an AR process using your autocorrelation and partial autocorrelation functions? Well, it turns out that autoregressive processes have exponentially declining autocorrelation functions and have spikes in the first one or more lags of the PACF. And it should be noted that the number of spikes in the PACF indicate the order of the autoregression. So in other words, if you've got 2 spikes in your PACF, that means you've got an AR2. If you've only got 1, then that means it's an AR1 process. And so just to give you a quick example, I've got a variable here which is called Lund price, and I just want to take a look at that. So if we want to take a look at both the autocorrelation function as well as the partial autocorrelation function, all we have to do is right click and click open, and then we click on view and we click on Correlogram. Leave everything the way it is, leave it at level, and click OK. Now, as you can see, my autocorrelation function declines very, very gradually. Now, the thing is, it doesn't decline exponentially, it declines very, very gradually. So the thing is, this probably is a non-stationary process. That means it's got a unit root. If it was stationary, it would be declining a lot more rapidly than this. Also, as you can see from here, the partial autocorrelation function only really has 1 spike there. None of the others really are significant. And so the thing is, we could conclude from this that it would fall into the category of being an AR1 process. In other words, its process might resemble something like this equation right here. Obviously you have to do more things, you have to do more tests after this, but that's what it looks like at the moment, just as an example. So I've just got some textbook examples as well of autoregressive processes. So if we just take a look at this, this shows you a standard AR1 process. You can see that the ACF is quickly declining towards 0. It's only got one spike in the PACF, and as you can see here, phi is more than 0. So if we just go back, this is what it looks like, and phi, this little Greek letter here, this little Greek letter that I've highlighted, that's a positive number basically. And but if, however, we looked at an example of an AL1 process where phi was less than 0, then this is what we'd expect. We'd expect it to go from 0 towards -1, and not like my Eviews example, which clearly shows it going towards 1 in a positive direction. This just shows you an example of an AR2 process. Again, it's relatively straightforward. It's pretty similar to the AR1 process, except this time it's got a second spike in the PACF. So just bear that in mind. And so now just moving on to moving average processes, which for the rest of this video I'll just be referring to as MA processes. MA processes are very simple as well. All they are is they're just equations where the dependent variable is dependent upon the current error term as well as some lagged error terms. So I've got an example, I've got a couple of examples actually here, where yt equals mu plus theta ut minus 1 plus ut. That's for a moving average 1 process. And then for a moving average 2 process, as you can see, it's literally the same, except now we've got 2 lots, and so the key point to take away is that when you see the number in brackets, that just means the number of lags. So if you had an MA3 process, you'd have another error term value, and it would say ut minus 3, for example. Now the key thing to bear in mind for moving average processes is that when you're looking at a correlogram like we just did on Eviews, the partial autocorrelation function is actually where you're going to see this rapid decline, and the number of spikes to identify the order of the MA process is actually found in the autocorrelation function. So just to give you a little textbook example, this is what it would look like if you were trying to identify an MA process. As you can see, the partial autocorrelation function this time is exponentially declining, whereas you've only got one spike in the ACF. So just remember, it's kind of like the AR processes and the MA processes, they're kind of like opposites of each other. That's the key thing to remember. So again, this is just an example of an MA2 process. This time, again, the partial autocorrelation function is the same, but the ACF has 2 spikes now, and that gives us an indication that it's an MA2 process. So I think this is pretty much all you need to know at an introductory level to understand ACFs and PACFs. And I suppose as well I should just give a warning that this doesn't necessarily give you the best armor model when you're estimating, when you're trying to fit your variables data generation process to an armor model. I'm actually going to be covering that in a future video. But nonetheless, this is still a good little introductory thing to do, just to take a look at, just to get an insight into the characteristics of your variable. Okay then, bye now.